Let's look at the method of undetermined coefficients. The superposition approach is what we sometimes call it for trigonometric functions. So suppose we have a differential equation of the form y double prime plus p of t y prime plus q of t y equals g of t, where g of t is a trigonometric function. This would be a non-homogeneous differential equation because the right side is not 0. How would we solve that? Let's look at an example. Find a particular solution of 3y double prime plus y prime minus 2y equals 2 cosine t. Notice, we're going to let y equal a cosine t plus b sine t. Why? Because 3 times the second derivative plus the first derivative minus twice the function equals 2 cosine t. If you're combining a function and its first derivative and its second derivative and you get cosine t, or a multiple of it, that's an indication that your original function is of the form something times cosine t plus something times sine t. So that's what we let y equal. And now if g of t were of the form a cosine kt, b sine kt, or a cosine kt plus b sine kt, we let y equal a cosine kt plus b sine kt. But here we have k equals 1, so we don't need to worry about that. Okay, we're going to plug in y and y prime and y double prime into the equation. We have y at the top here. We know what y is, a cosine t plus b sine t. Y prime will be negative a sine t plus b cosine t. Y double prime is negative a cosine t minus b sine t. We plug these into the above equation. We get 3y double prime, in other words 3 times negative a cosine t minus b sine t, plus y prime, in other words negative a sine t plus b cosine t, minus 2y. In other words, minus 2 times a cosine t plus b sine t equals 2 cosine t. So again, here's the equation we were looking at on the previous page. Let's distribute. We get negative 3a cosine t minus 3b sine t plus negative a sine t plus b cosine t minus 2a cosine t minus 2b sine t equals 2 cosine t. Let's combine the cosine t's. Negative 3a cosine t plus b cosine t minus 2a cosine t. Let's combine the sine t's, minus 3b sine t, minus a sine t, minus 2b sine t, and all of that equals 2 cosine t. When we combine those, we get negative 5a cosine t plus b cosine t, minus 5b sine t minus a sine t equals 2 cosine t. Let's compare the coefficients of cosine t and sine t. So notice the coefficient of cosine t on the left side is a negative 5a plus b, and the coefficient of cosine t on the right side is 2. So we have negative 5a plus b equals 2. On the left side, the coefficient of sine t is negative 5b sine t minus a sine t, so we get negative 5b minus a. And the coefficient of sine t on the right side is just 0, because there is no sine t on the right side. So we have negative 5b minus a equals 0. The solution to this system of equations turns out to be a equals negative 5/13, b equals 1/13. So those are the coefficients we want for cosine t and sine t, because again, remember, that's what we're looking for, y equals a cosine t plus b sine t. So our solution, our particular solution to the differential equation, is y equals negative 5/13 cosine t plus 1/13 sine t. Okay, so now let's solve the initial value problem. 3y double prime plus y prime minus 2y equals 2 cosine t. Y of 0 equals 0. Y prime of 0 equals 1/13. This is the same differential equation we just solved a moment ago, but now we have these initial conditions. The general solution of this differential equation, this non-homogeneous differential equation, will be y equals y sub p plus y sub h. Y sub p is one particular solution to the differential equation, and y sub h is the general solution to the corresponding homogeneous differential equation, 3y double prime plus y prime minus 2y equals 0. So notice it's homogeneous. It's got a 0 on the right side. Okay, we already know y sub p. Y sub p, we were told, or we calculated, is negative 5/13 cosine t plus 1/13 sine t. Let's find y sub h, the homogeneous solution, or the solution to the homogeneous differential equation. 3y double prime plus y prime minus 2y equals 0. We know how to solve this. We write it as 3r squared plus r minus 2 equals 0. Factor, and we get 3r minus 2 times r plus 1 equals 0. In other words, r equals 2/3 or r equals negative 1. That means our solution is going to be of the form y equals c1 e to the 2t over 3 plus c2 e to the negative t. That's our general solution to the homogeneous differential equation. Okay, let's put the pieces together. So our solution to the non-homogeneous differential equation, the general solution, is going to be y sub p, a particular solution to the non-homogeneous differential equation. That's this stuff over here. And then y sub h, that's our general solution to the homogeneous differential equation. And that's going to be c1 e to the 2t over 3 plus c2 e to the negative t. We want to find what c1 and c2 are. So let's plug in 0 because we know y of 0. Y of 0 is negative 5/13 cosine 0 plus 1/13 sine 0 plus c1 e to the 2 times 0 over 3 plus c2 e to the negative 0. This simplifies to 0 because, again, recall we saw a moment ago that y of 0 is 0 equals negative 5/13 plus c1 plus c2. So this leads to the equation c1 plus c2 equals 5/13. Again, we have y of t equals this. So that means y prime equals this. 5/13 sine t plus 1/13 cosine t plus 2/3 c1 e to the 2t over 3 minus c2 e to the negative t. Why on earth am I doing this? Because we know what y prime of 0 is. So let's plug in 0. Y prime of 0 is 5/13 times sine 0 plus 1/13 cosine 0 plus 2/3 times c1 e to the 2t, oh, that should be 0 over there, sorry about that, folks, plus minus c2 e to the negative t, that should also be a 0. Okay, so we know what y prime of 0 is, that's 1/13. The right side is 1/13 plus 2/3. That's going to be 1/13 over here. That's where that comes from. So plus 2/3 times c1 minus c2. So when we cancel the 1/13, we end up with 0 equals 2/3 c1 minus c2. So the solution to this system of equations, c1 plus c2 equals 5/13, what we saw earlier, and 2/3 c1 minus c2 equals 0, is c1 equals 3/13, c2 equals 2/13. So those are our values of c1 and c2. This was the general equation, but now let's plug in 3/13 and 2/13, and we end up with this as the solution to our non-homogeneous differential equation. Awesome!